We have solved exponentials getting common bases, we solved logs, and now we're going to solve exponentials using logs. So sometimes it's not possible to get a common base. So if you look at number 1, if this was 81 instead of 80, then I could totally get a common base, solve it like we've been solving it. But it's not 81, it's 80. So I'm not going to be able to come up with an exponent easily, a decent looking one, on my own without some help. So here's how we're going to use our logs. We isolate the exponential expression, meaning the exponential's got to be all by itself, which in number 1 it already is. Then I'm going to take the log of both sides, which is totally legal. Just like anything else you do, whatever you do to one side, you got to do the other, you're good to go. Once we take the log of both sides, then we can use the power rule to bring the x out in front, and then it's not in the exponent anymore, causing me issues. Step 4 says to solve and check for extraneous solutions. If I'm solving an exponential, do I need to check for extraneous solutions? Isn't this what a parent function of a log looks? I'm sorry. I'm not sure what just came out of my mouth, but if I solve an exponential, that's what I meant to say, not sure if that's what I said. When I solve an exponential, do I need to check for extraneous solutions? The answer is no. You have to for logs, but your parent function for your exponential looks something like that. Your domain's all real numbers, so whatever you get for x is fine. So this part right here doesn't make any sense. We're just going to solve. Now, when you take the log of both sides, the base of your log could be anything. Since we're going to use a calculator, the easiest thing for us to use would be to use the common log or the natural log, because those buttons are always easier to get to. You can take the log base anything that you want, but that's not necessary to get crazy. So we'll use the common log on this first one. So I'm going to take the log of both sides. So the log of 3 to the x equals log of 80. My power rule says that x gets to come out in front right here, so this will give me x times log of 3, no, not base 3, dang it, log of 3 equals log of 80. Trying to get x by itself, it's being multiplied by this, therefore I can divide, and I get x equals log of 80 divided by log of 3. It's not the log of 80 divided by 3, because we're not condensing logarithms, we're solving an equation here. At this point, now is when you would touch your calculator. You don't do it until the very last step. I would suggest hitting the fraction button first. That way you can just put the stuff in the numerator, put the stuff in the denominator. It's going to make it the easiest for you. All right, so then tell me, Gabriel, what did you get? Says you haven't. Well, let me see what you typed in. Oh, you have to close the parentheses. That's 3 point. How many decimal places? How many decimal places are you supposed to have? 3. Can you give it to me at 3? There you go. 3.989. Very good. Everybody get that? Make sure you're actually pushing the buttons on the calculator too. And on the TIs, a lot of times they'll let you not close the parentheses if it's at the end of something. This one pretty much makes you close your parentheses. So that's why you might get an error. All right, so let's look at number 2. Now number 2, we're going to use the natural log. Why? Just because. Because it doesn't matter either way, and natural log is less writing. So we'll do that. So I'm going to take the natural log of both sides. Natural log of 5 to the x plus 1 equals the natural log of 18. So now I use my power rule that x plus 1 is going to come out in front, and it's 2 terms, so it has to be in parentheses to look like this. Now, I could distribute that natural log of 5, but I'm trying to get x by itself, so I'd really rather not mix other stuff up with x if I don't have to. Sometimes you have to. Could I just go ahead and divide by the natural log of 5 here? I totally could. So that will leave me with x plus 1 equals the natural log of 18 over the natural log of 5. And again, not pushing that in the calculator yet because you can't round along the way. You can only type stuff in once. Then to get x by itself, I just subtract 1, so I get x equals natural log of 18 over the natural log of 5, and then minus 1. So on those calculators, when you're in the denominator doing the natural log of 5, you arrow to the right, it'll get you out of the fraction so that you can then do the minus 1. Okay? So go ahead and get it all typed in. And NIE, tell me what you got. Okay, 0.796. You'll agree with that? Yes. Awesome. Thank you very much. All right, so I want you to do one more thing on this one. Because I had a good question after we had moved on last period and came back, like, why do we use the natural log on this one? Well, it doesn't matter. We could have used the common log. So I want you to also type in x equals log of 18 over log of 5 minus 1. Now, the natural log of 18 and the common log of 18, two completely different things. Same with the 5s, but the ratio ends up being the same, so everything's the same. So type that in. Convince yourself that you get the exact same thing. That way it doesn't matter either way, okay? As long as you're using the same one on both sides, you're good. And if you don't get the same thing, let me know. Figure out what you did. We're good? Now, even though I have an option, whatever log I want to use, since number 3 has an e in it, I think I want to use the natural log. So, but I can't start off by taking the log of both sides because this isn't isolated. I got to move that 25. So this is going to give me e to the 3x power equals, what's 108 minus 25? 83. So let's just talk. I know you have a calculator in front of you, and use it. When you're allowed to use a calculator to do 108 minus 25 so you don't mess it up, okay? But if you didn't have a calculator, one way to think through it, because I think some of us always try and do things the hard way. If I do 100 minus 25, that gives me 75, and then I can add 8 back. Does that make sense? Learn how to manipulate numbers like that. I know some of you already do, and you were kind of taught those things. Some of you were never encouraged to do those things, so it's, you know, a little tougher, but it gets easier. All right, so now I'm going to take the natural log of both sides. So natural log of e to the 3x power equals the natural log of 83. So the 3x comes out in front. Natural log of e equals the natural log of 83. What is the natural log of e? If I said the natural log of e equals y, and I had to rewrite it in exponential form, what's the base of this log? E. So this would be e to the y power equals e. So what would y have to be for this to make sense? 1. If the base and the argument are the same, like log base 6 of 6 is 1. Log base e of e is 1. So this is just 1. If you didn't recognize that it was 1 and you left it as natural log of e, you get the same answer in the end, but it's going to make things a little bit easier to do because now that that's 1, that's kind of irrelevant right there, right? So now I just have 3x equals this, so I can just divide by 3, and x equals the natural log of 83 over 3. Type that in. And then Alexa, once you got that done, let me know what you got. I mean 1.47. Okay, 1.473. Y'all agree with that? Yes. All right. Thank you very much. Any questions at all before we move on? Awesome. All right. So let's look at number 4. So I need to isolate my exponential, which is that. So I got to get that by itself. So I'm going to start by adding 1 to both sides. So I get 2/3 times 2 to the x minus 6 power equals 42. Now I need to get rid of that 2/3 that's being multiplied, so I could divide, but what's another option? Well, yeah, but how? Multiply by what? The reciprocal. So multiply both sides by 3/2 so that these cancel out. That leaves me with 2 to the x minus 6 power. Then 42 divided by 2 is 21. 21 times 3 is 63. Now that you have your exponential isolated, you finish this one up. Angel, once you have an answer, let me know what it is. $11.977. Y'all agree with that? Yes. All right. Thank you very much. Good job. Well, good. Okay. So now let's look at number 5. On number 5, I got an exponential on both sides. They're both isolated. So I can go ahead and start by taking the log of both sides. So I'm going to have the natural log of 8 to the 2x minus 1 power equals the natural log of 5 to the x plus 3 power. So I use my power rule so that I end up with 2x minus 1 times the natural log of 8 equals x plus 3 times the natural log of 5. Now, on number 4, we chose not to distribute here because it was not necessary. We could just divide by the natural log of 2. Well, here, if I divide by the natural log of 8, then it gets in this fraction that also has an x in it, and it's a big hot mess. So in this case, we have to distribute in order to actually be able to solve it. So I'm going to distribute both sides. On the left, I will end up with 2x times the natural log of 8 minus the natural log of 8 equals x times the natural log of 5 plus 3 times the natural log of 5. Distribution, just like you've been doing forever. Now, just like any other equation that you've ever solved ever, whatever variable you're trying to solve for, you want to put all those terms with that variable in it on one side and everything without that variable on the other side. So I'll put all my x's on the left. So this is an x term right here, and so is this. So I'm going to subtract this over here. This will give me 2x times the natural log of 8 minus x times the natural log of 5. Then I want this natural log of 8 term right here to move to the other side. So then this will be 3 times the natural log of 5 plus the natural log of 8. Okay. So all my x terms are on the left. Everything that's not an x term is on the right. We good? Now, it would be nice if I could combine these, but I can't because they have different logs. Like if they were both log 8 or both log 5, then I could combine them, but it's not. It's like having a y and a z situation here. So I can't combine the two, but I'm trying to get x by itself. What could I do here? I could, what? That's not what you said. Is that what you said? Well, divide, what am I going to divide? Of the whole thing? I don't really have a math rule that allows me to do that. I know where you're going with that, but that's not the next step to do that. What could I do to get x by itself? Factor out the x, yeah. My GCF is x, so I'm going to factor out the x. That leaves me with 2 times the natural log of 8 minus the natural log of 5, which equals 3 natural log of 5 plus the natural log of 8. Okay, so let's pause here for just a second. This is 2. If this was 2x also, then my GCF would actually be 2x. But I don't know that I'd want to factor out my GCF because I don't care about getting 2x by itself. I care about getting x by itself. Does that make sense? If I was factoring for different purposes, then yeah, we always go with the GCF. But really, no matter what the GCF was, all I'm really trying to get out of it is x. Even if it was a negative, I wouldn't factor the negative out because that would just make things crazy, right? Just I'm trying to get x by itself. Boom, there's a little x. Now I can divide by this, which I think is where you're going, but you have to factor first, okay? So now I get that x equals 3 natural log of 5 plus the natural log of 8 over 2 natural log of 8 minus the natural log of 5. Now, I cannot simplify this fraction at this point, but even if I could, I wouldn't because I have to use the calculator. If you simplify things by hand, you run the risk of doing something weird. Let the calculator do it all. Push your fraction button first, go from there. Let's see what we get. Jenny, once you get an answer, let me know what you got. Okay, 2.710. Y'all agree with that? Yes? Awesome. What questions do you have? All right. I want you to do number 6 on your own. Let me give you a few minutes to get that done. Wasn't sure if both of those buttons were like an easy button or not. All right, did we all at least get to this point by now? Were you distributed? Okay. So now remember, we want to get all our x's on one side, so I'm going to move this to the left. I'm going to get negative 2x natural log of 9 minus 5x natural log of 2 equals 4 natural log of 2. Now here's where I could factor out a negative x, and in a different situation, maybe that would be the best thing to do. But I really don't want my x to be negative. I just want x. That's all I want. So I'm going to factor out x. That leaves me with negative 2 natural log of 9 minus 5 natural log of 2 equals 4 natural log of 2. Now, if you did factor out a negative x and then you took care of it in the end, that's fine. It's not wrong. It's just going to give you one more step. So then we should have x equals 4 times the natural log of 2 over negative 2 natural log of 9 minus 5 natural log of 2. Okay. Then you type all that in. Let's see. Joelle, when you get an answer, let me know what it is. And but again, whether you use the natural log or the common log doesn't matter. If you're using a calculator where it's easier to get to one button than the other, then choose that one, like whatever. But I think on most calculators, it's going to be just as easy to get either one. You all agree with that? Yep. All right. Good deal. That is it then. Any questions at all? Awesome. Your assignment is in Delta Math.